Here's a little intro into multiplying algebraic expressions. We know that when we see 3x, it really means 3 times x. So now, when we're looking at 3 times a 4x, what that really means is it's 3 times a 4 times an x. And rather than having these two grouped together, I'm instead going to group my 3 and my 4. Remember, the 4 is called a coefficient. And so the 3 times the 4 will give me 12. Multiply that by the x, so this would give me 12x. When you have variables, like a negative 5x times a 6y, you can rearrange the order. You're recognizing that this is negative 5 times x times 6 times y. And now I'm going to rearrange the order into this. And it used to be that these were grouped together, but now I want to group my negative 5 and negative 6. And maybe you are imagining that you're grouping, but maybe you're just recognizing that you just like negative 5 times 6 because you know you can multiply them together as integers. And so you would just have a negative 30xy. So again, when you look at negative 5x times 6y, you would get a negative 30xy. So do what you can, rearrange the order when multiplying because it is multiplication and order doesn't matter. In other words, it is commutative. Now, here we are multiplying x squared. So we have x times x times x cubed. So when in doubt, feel free to just write it out. And now you can see this is repeated multiplication 5 times. And so I have something multiplied 5 times, which means it's a power. So this would end up being x to the 5th. You might notice that what I just did was I added my exponents. So if we combined those, what I would want to do is look at my coefficients first and do negative 3 times 6 and get a negative 18. Then I want to look at my variables. I see that x to the 5th times x to the 7th. Now, based on what I did before, where I just added my exponents, I'm going to do the same thing, and I will get x to the 12th. And so, if you want to remind yourself how this rule of exponents works, when you're multiplying the same variable, so notice these are both x's, and when you're multiplying, you just add the exponent. So you'll see this sort of formula and reminder in your notes or in a textbook sometimes. So you'll see this formula or reminder in your textbook, or maybe that's, if that makes sense to you, it's something you want to put in your notes. So let's try one more. This is different because I have a negative 2x, and there's really no exponent on that x. Let's see. Well, let's just start with my coefficients. I'll get them out of the way. So negative 2 times 4. So I get a negative 8. Now, then I have an x times an x to the 5th times a y squared. I'm just going to focus in on my x's. And let's see. If I had an x and I multiplied it by like x cubed, I would end up getting x to the 4th. So that means that what I'm really doing is I'm still adding the exponent. It's just that this little exponent that's not actually written there really is a 1. So my x to the 1st times x to the 5th, 1 plus 5 is a power of 6. And then my y squared just gets tagged on. Now, if I wanted to write it like this, that works too. One thing we do not do in algebra is we don't put the coefficient somewhere in the middle. Like you wouldn't have y squared negative 8x to the 6th. That just doesn't make sense. And so there we go. That's a little bit of an intro into multiplying expressions. Here are 2 last ones. There's a baby crawling up the stairs. She's on her way to hunt me down. Let's see if we can finish this before she gets here. Now I'll take my x's, x to the 4th, and now I'll look at my y's. So y squared and negative y to the 4th. So my negative's going to go out in the front, and it'll be y to the 6th. So when I go through, I did the 6 and the 5, and I took care of the negative, negative 30. X cubed times x gives me x to the 4th. Y squared, y to the 4th gives me y to the 6th. Here's our last one. We would get a 42, g to the 5 and 4, 9th, h to the 2 and 7, 9th. Hi, Nova. Here comes the baby. She arrived and she said this expression is correct. Now the next hard part is differentiating between the difference between addition and multiplication. These types of problems we will navigate